Hello friends, welcome you all, and in this lecture we will discuss the normal forms of context-free grammar. And first of all I will tell you what these normal forms are and why do we need normal forms, and then we will discuss the example of each normal form there. So as you know friends, if I gave different people to write a grammar for some particular language, they may write different grammar for the same language. So to and if I want to implement something on computer, or you can say call on machine, so we need one specific form to represent that particular thing. So here normal forms provide a standard way of writing productions of the grammar so that we can implement them properly on the machine. There are two normal forms that are used commonly in theory of computation. So one is Chomsky Normal Form, and in short you can call it CNF, and other is Greibach Normal Form, in short you can call it GNF. So while we are using these normal forms, we can write the grammar in a specific format only. Now all productions of the grammar will be in a specific format only, and these formats we will discuss one by one for each type of normal form. Both these grammar does not have epsilon productions in here, and if your grammar is generating epsilon, or you can say the epsilon is the valid string for the grammar, then you can have only one epsilon production. To convert, if I want to convert any grammar into one of any of these two normal forms, so first I need to remove all epsilon productions and unit productions. First, both these kind of productions will be removed, and then we can convert them into normal forms. Now, after removing epsilon productions and unit productions, you can convert them into normal forms. So what these normal forms are, how we can use these normal forms, we will discuss one by one. So this step is common in both the normal forms, so we can use them. So now I will take Chomsky normal form first, and I will show you how to represent, how to write production of Chomsky normal form in particular format. So friends, we can start with the Chomsky normal form. So in Chomsky normal form, there may be two kinds of productions only, which are A gives BC, A gives BC, and A gives small a. That means only two types of productions are possible in Chomsky normal form, where in first format of production, there will be left hand side will have only one variable, and right hand side will have exactly two variables, and right hand side will have exactly two variables. So this is one format of production in CNF, and other format is A gives small a. That means left hand side one variable will be there, and right hand side one terminal will be there. So these two kinds of format are possible in Chomsky normal form, and if you want to convert any grammar into Chomsky normal form, then you need to arrange all the productions in these two formats only. So I will take one example here to convert this into Chomsky normal form. So friends, this is one example grammar that we need to convert into CNF, and you can see here in this grammar we have epsilon production, we have unit production. So I have taken this example purposefully to explain the conversion of into CNF. So that will use all concept there, removal of all steps there. So sometimes you may have any grammar which is not having any unit production or any epsilon production or both. So that would be very simple to convert into CNF. So now I have taken this example. So we will solve this example by step. So the conversion process will be more clear to all of you. So now we can start with the. So first we can see here the grammar is given to you. There are 3 plus 2 plus 2, 7 productions are there, and 3 variables are there. 3 variables are there. So you can see, my friend, this This production is having three variables, which is not allowed in CNF. This production is having one terminal and one variable, which is also not allowed in CNF. This is having one terminal, which is allowed in CNF. So again, we have two unit productions. So A gives B and A gives S. B is having two production here. B gives B and B gives epsilon here. So now this production is already in CNF. This production is already in CNF. So first we will try to remove A, B gives epsilon and this unit production. So you can see, my friend, this particular grammar is having two unit production and two epsilon production. And now you can wonder why two unit products, epsilon production, because B is giving epsilon. So this is one production, B gives epsilon, and A is generating B. So indirectly, it is also generating epsilon. So this particular grammar is having two unit production as well as two epsilon production. So now we will first try removing both these productions of here. So if I say, let's remove this B gives epsilon, remove this B gives epsilon. So if I take all, if I want to remove B gives epsilon, then I need to see all the productions where B is at right hand side. So we have two productions where B is at right hand side. So here, if I replace B with epsilon, so S gives A will be the new production. So I can add this production here. Now, in this particular production, if I replace B with epsilon, so this will give us A gives epsilon. So now we can remove this particular production from here. Now, as we are having A gives epsilon now, so we can remove this production from the grammar. We have only one production where A is at right hand side. So now you can see, if you replace A with epsilon in this production, so there are four possibilities. There are four possibilities. So this production is already there. This production is already there. Three more possibilities are there. What? So first you replace this A with epsilon. So it will add SA as new production. Then you replace this A as epsilon. So this will give AS new production. Now if you replace both these A with epsilon, so it will gives us S gives S. So this production is unit production and it is meaningless production because it is self unit production is there. Both the side we have only one variable which is same. So this production we will not add. This is useless production simply, right? So we have now how many productions of S? 1, 2, 3, 4, 5, 6 productions we have for S. Now you can see as A gives B is there. So if I replace this B with, see now we have removed this A gives epsilon also. Now first we removed epsilon production. Now we will remove unit production from this grammar. Now you can see, my friend, this particular variable is generating B. A gives B. So now if I replace this B with its production, so this will gives us new productions as B. A gives B. Now one more production is there. So I can remove this. I can remove this. Now one more production is there. A gives S. A gives S. Now if I replace this S with all its production, then you can understand that all productions are will also generate these all productions will be repeated in A also. So that in that case you will have A gives ASA, AB, B, A, SA, and AS. So all these productions will be copied to A also. Now this is the grammar that we have got after removal of epsilon production and unit production. Now, in that particular grammar, again you can see how many productions are there which are already in CNF. So we can see as gives A, B, as gives A, both are in CNF. This is also in CNF. These are two productions are also in CNF. So similarly with A, these two are in CNF, these two are in CNF. Now the only thing we have here, now you can see we have this is not in CNF, this is not in CNF. So what we can do, we can use one to have this production. We can create, see, when you are converting any grammar into CNF, then you may add some products variable there, and if you are adding some variable, then obviously you will add their productions also. So now, as we have here three productions, three variables in the right hand side, so we can create one, we can introduce one new variable here. You can understand, like I can have any new variable there, so I can use p, and p gives now as. Now if I replace this as with p, so now this would be as gives ps pa. Then if I replace this a with q, q gives a. So now I can write it QB. Now this is already in CNF. 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 Similarly with A. So now I can write PA, then QB, then B, then A, then SA, then AS, then B gives B is already there. So now, as we have introduced two new variable P and Q here, so I will write their production here after these productions. So I can write it like this. P gives AS and Q gives A. So now you can see, my friend, all these productions are in CNF. All these productions are in CNF, and this is the grammar which is equivalent to this grammar and in CNF. So I hope this would be very much clear to all of you.